This is my beginning algebra course. Today we're going to learn additional problems on linear equations and their graphs. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. These types of problems are such a big part of this course that we're going to do another class on writing linear equations and drawing their graphs. There's so many varieties of these types of problems that we're going to do a whole class to expand on what we learned in the previous classes. So let's get started. For each problem below, write an equation of the line with the given characteristics. So we're told that this line has an x-intercept of -5 and a y-intercept of 2. So let's review what intercepts are. If you have a graph, and let's say just give some hypothetical line, and let's say that it crosses the y-axis at 4 and the x-axis at -4.5. The x-intercept would be -4.5 because that's where the line crosses the x-axis. Remember, this is the x-axis, and this is the y-axis, and this is the y-intercept. 4 is the y-intercept because that's where the line crosses the y-axis. But I want you to understand that you can also write the x and y-intercepts as ordered pairs. You can write them as just single numbers as you see here, but you can also write them as ordered pairs. So we learned in a previous class that when a point is on the y-axis, the x value must be 0. So this is the point on the y-axis, the y-intercept. So this is what I mean when I say you can write it as an ordered pair. So you can, in this particular example, you can write the y-intercept as just a single number. You can say the y-intercept is 4, but you can also say the y-intercept is 0, 4. So again, this is just a different variety of these types of problems. And the x-intercept would be -4.5 and 0 because if a point is on the x-intercept, then the y value must be 0. Now, do you see why that is? Do you see why the x value of the y-intercept must always be 0? Because it's right on the y-axis. That means that you're not counting out to the right or to the left any units. You're just right on that y-axis, so the x value must be 0. And if you're on the x-axis, then the y value must be 0 because you're not counting up or down any units. Now we learned how to graph a line given the x and y intercepts in a previous class. Remember, in order to find because we have to find 2 points to graph a line, and in order to find the y-intercept, you set x equal to 0, and to find the x-intercept, you set y equal to 0. So we already went over this in some detail. So that's just some review to figure out how to do this problem. So again, we're looking for the equation of the equation of the graph that has the following x and y intercepts. So because the x-intercept is -5, we know that -5, 0 is a point that's on the line. And because the y-intercept is 2, we know that 0, 2 is a point that's on the line. So we have 2 points on the line. There's a number of ways that we can find the equation of the line, because again, that's what we're looking for. It says, for each problem below, write an equation of the line with the given characteristics. So we have an x-intercept and a y-intercept, and we have to write the equation of the line. So I wrote these points here, and I'm going to do it the easy way first. So the easy way is to use y equals mx plus b. Now, remember, this is slope-intercept form. We don't have the slope, but we do have a point we can plug in, x and y, and we do have b. b is the y-intercept. So b is actually 2. So we can go ahead and just plug in 2 for b. And if we use this point in x and y, 0 here and 2 here, that's actually not going to give us any additional information. So we have to use this other point here. That's an important thing to remember. So instead of y, we're going to plug in 0. And instead of x, we're going to plug in -5. So I'm going to color code that just to make sure you know what's going on here. So now we just solve for m. Subtract 2 from both sides, divide both sides by -5, and we get m is equal to 2/5. So why did we do that? Well, we did that because we were, again, looking for the slope. Because once you find the slope, you can just write the equation of the line. We know the slope is 2/5, and we know b. We already knew what b was. That's 2, because that's the y-intercept. So it would just be +2, and you're done. So that's the way that I prefer to do these particular problems. Now for number 2, I'm going to try a different method. So again, we have an x-intercept and a y-intercept. So for this problem, I'm going to use the slope formula. M is equal to y2 minus y1 over x2 minus x1. So I'm going to plug in these 2 points and find the slope on the first step. And we can see that the slope is going to be -3. So now I have the slope, and I already have the y-intercept. So I can just write the well, actually, I can go ahead and I can write the point-slope form of the equation, or I can write the slope-intercept form. I'm just going to write slope-intercept form. Y is equal to mx plus b. So we're going to plug in m, which we just found is -3, and b, we know b is the y-intercept. It's extremely important to understand that b is the y-intercept. You must remember that. So we're just going to plug in 3 there, and we're done. But I just want you to be aware that you could also use point-slope form. You could write, you could use this equation here. And you could plug in one of these points. It doesn't matter which one. I'll use the first one. Whoops, that'd be -3 for slope, and x minus 1. So that's also another answer that you could give, but I don't have enough room to show both those answers, so I'm just going to get rid of that one. Again, there's often multiple ways to do these problems. All right, so let's do number 3, and then you can do the next 3 problems on your own. So again, we have the x-intercept is -2, 0. The y-intercept is 0, -4. And I'm going to use this easier method. I prefer that the y equals mx plus b method, slope-intercept. So we're going to use the slope-intercept equation. And again, the whole point of this is to find equations of the lines that have these characteristics. So we're looking for equations. So for the point, I'm going to plug in 0, which comes from here, and I'm going to plug in x, which comes from here. I'm not really going to be able to use arrows, so I'm going to just color code. And b, I know, is -4, because b is the y-intercept, and -4 is the y-intercept. All right, so I just add 4 to both sides, divide by both sides by -2, and I get m is equal to -2. Now I can just write y equals mx plus b, write it in slope-intercept form, and m we just found is -2, and b we already knew was -4. b is the y-intercept. We were given the y-intercept in the beginning of the problem. Now it's time for you to try, so I'm going to leave those in the window. Try number 4. And when you come back, we'll do it together. All right, we're back. So we have 2 points, 6, 0, and 0, 1. So I'm going to use y equals mx plus b because that's just my preferred method. And y is going to be 0, x is going to be 6, b is going to be 1. I got b from here, and I plugged in the point to x and y. Now again, you can use this as your b value, but you can't plug in this point to x and y because that will not give us additional information. So these are all things you're going to need to pay attention to. So subtract 1 from both sides, divide both sides by 6, and you get m is equal to negative 1/6. So now we can just write the equation of the line. So y equals mx plus b. And again, you could write point slope form if you wanted to, but I would prefer just slope-intercept. So plug in the slope, which we just found is negative 1/6, and b we already knew was 1. Remember, b is the y-intercept. So if you got that equation, that's very good. Try number 5, and when you come back, we'll do it together. All right, we're back. So the slope is 1/4. And now we can write y is equal to mx plus b. We know m, we just found m. And we knew b was negative 2 from the very beginning of the problem. Sometimes I'm color coding, sometimes I'm just writing an arrow for certain things to try to demonstrate. So if you got that answer for number 5, good job. Try number 6, and when you come back, we'll do it together. All right, we're back. So this information tells us that we have 2 points, negative 1, 0, and 0, negative 1. 2 points on the line. And so we're going to use y equals mx plus b. Again, that's just my preferred method. Again, I showed you this method. If you want to use this method, you can. There's multiple ways to do these problems. So it can be kind of confusing for students. You can just stick with one method if you want, unless your homework tells you to do it in a certain way. Obviously, you need to stick to that way in that circumstance. So I'm going to plug in the x value. So 0 for y, negative 1 for x. Then plug in b, which is negative 1. Add 1 to both sides, divide both sides by negative 1, and m is equal to negative 1. Then we just write y equals mx plus b. M is negative 1. B is negative 1. So if you got that answer, good job. All right, so we're continuing with different variations of problems. In all those problems that we just did, we were given the x and y intercepts, and we were asked to find an equation of the line. So now we're going to be given a lot of different information, a lot of different types of information. In this first problem, we're given the slope of the line and where the line crosses the x-axis. So if this were the y-intercept, then we could just write slope-intercept form. We could just write y is equal to negative 2x plus 3, and we'd be done. Because remember, this is called slope-intercept form because you're given the slope and you're given the intercept. But this has to be the y-intercept. This is always the y-intercept. We're not given the y-intercept, so we can't just write the slope-intercept form immediately. So the way I'm going to do it is I'm going to say, okay, well, the x-intercept is still a point. It's 3, 0. And the slope is -2. So do you see what's happening here? I have a point and I have a slope. So look at your three equations. You took screenshots of those three forms of linear equations. You had standard form, slope-intercept form, and point-slope form. If you have a point and the slope of the line, obviously you're going to use point-slope form of the line. That's the easiest way to do it. So y minus 0 is equal to -2 times x minus 3. And I'll color code that in case you don't know where those numbers are coming from. And there you go. So that just happened to be the easiest way, in my opinion, to write an equation of the line. Again, the instructions don't tell us what form of a linear equation to use. So we can write any form. So if I want to write point-slope form, I can, because that's just the easiest form to choose. Now, number 8, we're given a point, just a random point, and the y-intercept. So I'm going to use y equals mx plus b. And I'm going to use 2 for the y value, and we don't know the slope, -1 for the x value, and we know the y-intercept is 3. So I just plugged in all that information. I used a point. My point was x and y. So x and y. And maybe I should color code that. So there's the y value. There's the x value. And the y-intercept. So now I just have to solve for m to find the slope. And by the way, I'm kind of rushing through that, but if you multiply m times -1, you get -m minus 3. But I just don't really have a lot of room to do that. But again, this is just a simple pre-algebra equation. If you're having trouble doing that, then you should go back to my pre-algebra course. Add 3 to both sides, divide both sides by -1, and we get -5. So m is equal to -5. So now we can just write y is equal to mx plus b. But I don't really have enough room to write it, I guess. Might just move these up, maybe. And so y is equal to mx plus b, and we just plug in m and b, and we're done. So m is -5, and b we knew it was given in the equation is -3. So again, in these problems, you're just given different information, and you have to take that information and figure out how to write an equation of the line. So number 9, we're given the slope and the x-intercept. So again, let's just make the x-intercept a point. And we have the slope, so that means we can use point-slope form. Y minus yp is equal to m times x minus xp. In fact, I should have wrote this. I didn't write this equation in the previous problem. I'm going to do that. Again, you should have these equations right in front of you, so I shouldn't have to write them for you, but I just want you to recognize what equations we're using. So again, we have a point and slope, so we use point-slope form. That's where I got this. That's just the easiest way to go with this problem. Y minus 0 is equal to slope, which is -2/3 times x minus 1. And there you go. Again, if you want that color-coded, it would be like so. Just to show you where all those numbers are coming from. All right, time for you to try. These two problems are going to be really easy. Much easier than the problems we did here. See if you can figure out why. Again, you should have those three forms of those equations, those linear equations right in front of you. If you don't have those equations right in front of you, then you're going to be completely lost. So you should have y equals mx plus b, y minus yp equals m times x minus xp, and you should have ax plus by equals c. And you should also have the equation where we find the slope using y2 minus y1 over x2 minus x1 in case we do need that. So try number 10, and when you come back, we'll do it together. All right, we're back. Again, these problems are not going to be exactly the same as these problems because we're doing different variations of these problems. We have the slope of the line and we have a point on the line, so we're just going to use point-slope form. It's so easy if you understand what those equations are referring to and what the names tell you about the equations. So the y value is 1, the slope is 1/2, the x value is 7, and it's just that simple. You're done. So if you know what you're doing when it comes to those equations, that one was pretty easy. Try number 11, and when you come back, we'll do it together. All right, we're back. This equation is really easy too because we have the slope and the y-intercept. Now, in the previous problems, we had the slope and the x-intercept, so we couldn't use slope-intercept form because the intercept in the slope-intercept form is only the y-intercept, it's not the x-intercept. I know what you're thinking. You're thinking, that sounds really boring to have to remember. Well, you're going to be doing this stuff thousands and thousands of times, so you better remember it quick because there's no point in resisting. So we're going to use slope-intercept form. We have the slope and we have the intercept. And it's the y-intercept. So slope is -3 and y-intercept is 5/4. And that's it. So easy. Again, some of these problems can be really easy if you know what you're doing. All right, try number 12. Number 12 is going to be a little harder because we're not given the y-intercept, we're given the x-intercept. So you have to change that x-intercept into an actual point, like I did up here. Try number 12. When you come back, we'll do it together. All right, we're back. So the x-intercept is just a point. It's just 4, 0. And we also have the slope of the line, which is 5. So we have a point and we have the slope. Well, obviously, we're just going to use point-slope form because we have a point on the line and we have the slope of the line. Y minus 0 is equal to 5 times x minus 4, and it's just that simple. And by the way, you might be wondering, can I get rid of this 0 here? Do I have to have that 0? Well, yes, you can get rid of it if you want, but I'm just going to keep it there because I want you to recognize the form here. All right. Now these are going to be new problems, these next problems here. We're told to find the equation of the line that has a y-intercept of -4, and the line itself is parallel to this line. So this is not our line. We're looking for an equation of our line, but this is not the equation of our line. This is just an equation of a line that is parallel to the line that we're trying to study here. So I know that seems kind of complicated, but don't worry, this is really simple. So if two lines are parallel, that's what that means. These lines are parallel. It means that they're never going to touch each other. They're never going to hit each other. So for these lines are not parallel because they cross. And of course, I'm talking about two-dimensional lines. I'm not talking about three-dimensional. Then it gets a little more complicated. In fact, a lot more complicated. But in two-dimensional space, parallel lines are never going to cross. So these would be parallel lines. If two lines are parallel, that means their slopes are equal. So I'm going to go ahead and write that. Parallel lines, slopes are equal. You really need to remember that. The slopes of parallel lines are equal. All right, so the y-intercept is -4, and the slope of our line, the slope of this line, you see this is in slope-intercept form. It's in slope-intercept form, so we can see the slope of this line is -6/5. But because our line is parallel to this line, our line has to have the same slope. So our line has a slope of -6/5 too. So our slope is -6/5, and our y-intercept is -4, because we were told that. So if we have the slope and the y-intercept, then we can just write the slope-intercept form of the equation. So m is equal to -6/5, b is -4, and you're done. Very, very simple. Again, if two lines are parallel, then the slopes are the same. So again, this is asking, find the equation of the line with y-intercept -4, and that's parallel to this this line here. So our line is parallel, so we knew it had the same slope. So that's the slope of our line, because it's the same slope of this line. And we were told the y-intercept was -4. So given this information, slope and y-intercept, we could just write the slope-intercept form of the line immediately. So again, see, these lines are not the same. They're parallel, but they're not the same. So don't be confused by that. You know what? I'm going to rewrite this, because the more I look at that, the more I think that's just a weird form. The slopes of parallel lines are equal. Extremely important. All right, next problem. Now we're going to do perpendicular lines. So perpendicular lines are lines where they make a perfect cross. That means that the angle in between those lines is 90 degrees. It's not really that important that you understand the actual the value of the angle, but that's just what perpendicular means. It means the lines make a perfect cross with a 90-degree angle between them. So well, first of all, we know the y-intercept is 3/7. So we're given the y-intercept just like we were given the y-intercept in the previous problem. But we need to find the slope. So if this line here is perpendicular to our line. So if two lines are perpendicular, then the slopes are negative reciprocals. Now the phrase negative reciprocals is just a fancy way to say that you take the slope of this line and you flip it so it becomes 5/4, and you change the sign. So we put a negative. So if you start with a positive number here, it changes to negative, and if you start with a negative number, it changes to positive. So again, we flipped it and we changed the sign. So I'm going to move this down so I can write that general rule. The slopes of perpendicular lines are negative reciprocals. So now we can use y is equal to mx plus b, and m is -5/4, and b is 3/7, and we're done. So that's the equation of the line. All right, on to number 15. So see if you can do number 15. Again, if the lines are parallel, that means the slopes are equal. So try number 15, and if you get stuck, we'll do it together. I'll see you when you come back. All right, we're back. So we know the slope of this line is 3 because it's in slope-intercept form. We can see the slope. And because our line is parallel to this line, the slope of our line, it must be 3 also. We also know that the y-intercept is 1 because they tell us that information. So the y-intercept of our line is 1. And we know the slope of our line is 3 because it's parallel to this line, and the slope of this line is 3. So again, if lines are parallel, the slopes must be the same. So then we just use y equals mx plus b. And we have, just plug those numbers in. So y is equal to the slope times x plus 1, y-intercept, and there you go. So if you got that answer, good job. All right, and why don't you try number 16? Again, look at the slope of this equation. We can see the slope because it's in slope-intercept form. That means that the y is by itself. So it's y equals mx plus b, and this is m. This is the slope of this line. But our line is going to have a slope that's different because these lines are perpendicular. So you just take this value and you flip it and change the sign, and that's your slope. And this is the y-intercept of our line. So write the equation of the line that is perpendicular to this line and contains this y-intercept, and when you come back, we'll do it together. All right, we're back. So our slope is going to be positive 9/7. I flipped it and I changed the sign. That's our slope. Again, because it's perpendicular. And our y-intercept, we were told, is negative 10 over 11. So now I can just use y equals mx plus b, slope-intercept form, and I'm using slope-intercept form because obviously I have the slope, which is 9/7, and the y-intercept, which is negative 10/11. So if you got that answer, good job. If you got stuck, that's okay. You'll figure it out eventually as we go along here and do more problems. It takes a while to get used to this stuff. You know what, I'm going to change that 9/7 so it's level. All right, so try number 17, and when you come back, we'll do it together. All right, we're back. So our line is parallel to this line, so our slope is 3/8, and we're told that our y-intercept is 0. So that's all the information that we need. We can just use y equals mx plus b. M is 3/8, and b is nothing, so that's the answer. So if you got that answer, good job. Try number 18, and when you come back, we'll do it together. All right, we're back. So our y-intercept b is equal to 13, and our slope is equal to negative 7/5. And again, the reason we can do this is because this is in slope-intercept form. We can see the slope is right there, so we can use y is equal to mx plus b, and that's our answer. Sorry I didn't give you more room here to write. All right, so we're going to do the next one together. The y-intercept is 3/4, and our slope is going to be the negative reciprocal. But the problem is we don't have a fraction, so what do? Well, we just write this 3 as over 1. And then we can flip it at that point and change the sign, so it becomes negative 1/3. So no big deal. So if you get a whole number, that's how you deal with it. So our slope is negative 1/3. So now we can just use y equals mx plus b, so y equals mx plus b. So the only difference with that problem is we had a whole number as a slope. So try number 20, and when you come back, we'll do it together. All right, we're back. So we know the y-intercept is 2 because it tells us the y-intercept of our line is 2. And our line is perpendicular to this line, which means that our slope is going to be the negative reciprocal of this slope. So that would just be positive 1/5. The slope of this line is negative 5. How do I know that? I know that because this line is in slope-intercept form, y equals mx plus b. So I know that this is the slope. M is the slope. So I can just find the negative reciprocal, and now that's the slope of my line because I know it's perpendicular to that graph. So y, now I can just write the equation of our line, y equals mx plus b. So if you got that answer, good job. Again, this negative 5 is over 1, so if you flip it, it becomes 1/5, and obviously you change the sign. Whoops. I'm missing an equation there. There we go. All right, so for number 21, we have the same situation. But instead of giving the y-intercept for these problems, they're just giving us a point. So these are going to be slightly more difficult. So we know that our line is parallel to this line. And we know the slope of this line, because this is in slope-intercept form, the slope of this line is 3. So the slope of our line must be 3 also. So we're going to write m is equal to 3. And we have the point 1, 4. So now that I think of it, this is actually not any more difficult than the previous problems because we have a point and the slope of the line, a point on the line and the slope of the line, so we can just use y is equal, or y minus yp is equal to m times x minus xp. Plug in y is 4, plug in m is 3, and there you go. Again, we don't have to put it in any particular form. We just have to find some form of a line. It doesn't tell us which form to find. So because I have a slope and a point, I can just use point-slope form. All right, now we go into the perpendicular situation. So this equation is in slope-intercept form, which means I know that this is slope. The slope of our line is going to be the negative reciprocal, which means you just change the sign and flip it. And why is it negative reciprocal? Because our line is perpendicular to this line. And then we have the point negative 3, 2, so we have the slope and a point. So we're going to use point-slope form, just like we did in the previous problem. So y minus 2 is equal to the slope, which we found is 2/3 times x minus negative 3, but minus negative 3 you know is just going to be plus 3. So these problems are really easy. So now it's time for you to try. Go ahead and try 23, and when you come back, we'll do it together. All right, we're back. So the slope of our line is 7/4, and we have a point on our line, which is negative 2/5. So we just use point-slope form. That's the easiest way to do it. Plug in the values. And there you go. So if you got that answer, good job. All right. Remember, if lines are perpendicular, you have to flip the slope. Find the slope on the other line first. Then flip it and change the sign, and that's the slope of our line. So try 24. When you come back, we'll do it together. All right, we're back. So the slope of our line is equal to negative 1/2 because I just wrote 2/1, and then I flipped it and changed the sign. And we have a point on our line, which is -2, -2. So now we have a point in the slope, so obviously we're just going to use point slope form because we can just plug in the point and the slope and then we're done. Y plus 2 is equal to -1/2 x plus 2, and we're done. So if you got that answer, good job. All right, so try number 25, and when you come back, we'll do it together. All right, we're back. So our slope is -2/5, and we have a point -2, -5. Use point slope form. I'm not going to keep writing the equation because it's going to take forever if I have to keep writing that equation. So if you got that answer, good job. Try 26. When you come back, we'll do it together. All right, we're back. So the slope of this equation is the coefficient of x, because it's in slope-intercept form. The coefficient of x is just 1. So if you take 1 and write it as over 1, because remember 1's a whole number, so you can write it as over 1, then you just flip it. But if you flip it, you get the same thing. So all we have to do is just change the sign, and it becomes -1. Again, the slope of this line is 1. So if you write 1 as over 1, because you can write any whole number as over 1, you just flip it at that point, change the sign, and you end up with -1/1, which is -1. And the point on our line is 2, 6, so we just use point slope form. And remember, we don't need a -1 coefficient here, we just need the negative sign. So if you got that answer, good job. If you didn't get that answer, that's okay. Now you know what to do. All right, so for number 27, something different is going to happen. We want the equation parallel to this equation, but notice that this is not in slope-intercept form anymore. It's in point-slope form, but that's no big deal. We can still see the slope easily. So our line is parallel to this line. So remember, point-slope form is in y minus yp equals m times x minus xp. What that means is that 3 is the slope. So we can see the slope of that line just by looking at it. So because our line is parallel, the slope of our line must be the same as the slope of this line. So the slope of our line is 3, and we're told that 7, 3 is a point on our line. So obviously we're just going to use point-slope form to find an equation of our line. And we're done. So the only difference with these problems is that you're given point-slope form. So the slope is going to be this number. The slope of this line is going to be this number. But if it's perpendicular, obviously you have to change it. Whereas these equations were slope-intercept form. So this number was the slope. All right. So number 28, again, we have the same situation. This is in point-slope form, which means that this number is the slope. That equation is kind of turned around a little bit, so don't worry about that. No big deal. The y is on the right side, but that's okay. You can do that. So the slope of our line is positive 8/7 because you flip and change the sign. And we're told that -4, 1 is a point on our line. So we just use point-slope form as usual. And there we go. Now it's time for you to try one of those problems. Try number 29, and when you come back, we'll do it together. All right, we're back. So the slope of our line is 3/4. And we have a point on our line. And then we just use point-slope form. And we're done. So we got that answer. Good job. Try number 30. When you come back, we'll do it together. All right, we're back. So the slope of our line is going to be negative 1/2. How do I know that? Because the slope of this line is 2. How do I know that? Because this is point slope form, which means this number is the slope. So 2 over 1 is the slope, so I switch it so it's 1 over 2, and I change the sign. So again, remember, if it's a whole number, it's always considered to be over 1. And of course, we have the point negative 2, 0. And we just write the point slope form of the line. So we got that answer. Good job. All right. So here's some different variations of these problems. These problems are going to be more difficult. We're told to find an equation of the line with y-intercept negative 2, and that's parallel. The line itself is parallel to this line. So we know that the slope of our line is the same as the slope of this line. The problem is we don't know what the slope of this line is. The reason we can't see the slope is because this equation is not in slope-intercept form. It's not in y equals mx plus b form. If it were, we could see m just by looking at it. And it's not in y minus yp equals m times x minus xp form, point slope form. If it were, we could just see the slope by looking at m there. This equation is not in slope-intercept form or point slope form. It's in, what form would that be? What form is that? That is standard form. So standard form doesn't give us any useful information, so we can't see the slope. We have to change this form to slope-intercept form, and then we'll be able to see the slope. So in this problem, all we have to do is just subtract 3/5 x from both sides, and we get y is equal to negative 3/5 x minus 4. So all we did was just change the form of that equation. So because we changed the form, we can now see, again, this is y equals mx plus b form, so we can see that negative 3/5 is the slope. So that means that our slope is also, the slope of our line is negative 3/5, because we're told our line is parallel to this line. And we also have a y-intercept of negative 2. So this is going to be really easy. We have the slope and the intercept, so we can just use slope-intercept form. And we're done. On to number 32, we got the same situation. We have the standard form, so we know that the slope of our line is going to be the negative reciprocal of the slope of this line, because the two lines are perpendicular. Problem is we don't know what the slope of this line is because it's in standard form. So we have to convert this form to slope-intercept so we can see the slope. So I'm going to subtract 8x from both sides. Then I'm going to divide both sides by negative 2 because I have to get y by itself. Remember, in y equals mx plus b form, y is by itself. We have to get y by itself. All right, so now it's in slope-intercept form, and I can see the slope of this line is 4. So that means the slope of our line is going to be the negative reciprocal of that, which would be negative 1/4. And we have the y-intercept is 4/5. The y-intercept on our line is 4/5. So therefore, we can just use y equals mx plus b. Maybe I should show that equation that we used. All right. So now it's time for you to try one of those problems. Again, we're given the y-intercept. We're given lowercase b. Lowercase b is 7. But we're given the standard form of this equation and told that our line is parallel to this line. So the slope of our line is going to be the same as the slope of this line. Problem is, we don't know what the slope of this line is because it's in standard form. Standard form doesn't tell us anything. So you're going to need to change the standard form into slope-intercept form, meaning get y by itself, and then you can see the slope. Then using the y-intercept and the slope, you can write slope-intercept form of the equation and you're done. Try 33. When you come back, we'll do it together. All right, we're back. Let me get rid of that b equals 7. So I'm going to add 10x to both sides. Divide both sides by 5. And so now we can see the slope of that line. The slope is 2. So the slope of our line is also 2 because our line is parallel. And we know the y-intercept is 7 because they told us that. Again, these are all characteristics of our graph where we're acting as detectives trying to figure out the mystery or the solution to the mystery, which is the equation of the line. Now we're going to use y equals mx plus b form, slope-intercept form. We know m is 2, and we know b is 7. So if you got that answer, good job. Again, you must convert this form into slope-intercept form so we can see what the slope is. Try number 34. When you come back, we'll do it together. All right, we're back. Let's see. Subtract 4x from both sides. Divide both sides by -3. And now we can see that the slope of that line is 4/3. So the slope of our line is -3/4. Whoops, that should be slope. And we know the y-intercept is 0. So we can just use y equals mx plus b form and just plug in m is -3/4 and b is 0. So that is our answer. So if you got that answer, good job. All right, so let's do number 35 together. It's the same problem pretty much. We have to convert this standard form equation to slope-intercept form. Subtract 7x from both sides. And by the way, you can write the 7x on the other side if you want, but it's just going to look strange because it's not going to look like the general form of the slope-intercept equation. All right, divide both sides by 5. So now we see the slope of that line. And the slope of that line is going to be the same as the slope of our line because the lines are parallel. So now we have the slope and we have a point. The slope of the line that we're looking for, an equation for, and we have a point on the line. So now we can just use point slope. And you're done. Let's try one more of these types of problems. The only difference with this problem is now you're plugging in a point and using point slope form, whereas in this problem you're given the y-intercept, so obviously you want to use slope-intercept form because again the intercept in slope-intercept is the y-intercept. All right. So we have to get this standard form equation in slope-intercept form so we can see the slope. Add 2x to both sides. Divide both sides by 10. And remember, whenever you're dividing a polynomial by a monomial, you just divide each term, like you see here. Divide each term. All right, so I can reduce 2 over 10. That becomes 1 over 5, but I don't have to write the coefficient on the x. And so now we have slope-intercept form, which means we can see the slope. But it's kind of hard to see the slope unless you factor out the 1/5. Now we can see the slope is 1/5. So because our line is perpendicular to that line, our slope is going to be the negative reciprocal, which would just be -5. And we're told that we have a point, -2, -2. So now we can just use point slope form because we have a point and we have the slope of the line. So y plus 2 is equal to -5 times x plus 2. All right, so try number 37. And when you come back, we'll do it together. All right, we're back. Add 5x to both sides. Divide both sides by 2, and now we can see the slope of the equation because it's in slope-intercept form. And so our line is parallel to that line, so the slopes must be the same. So the slope of our line is 5/2, 2. And we also have a point on our line. We're given a point, so obviously we use point slope form. So if you got that answer, good job. Try 38, and when you come back, we'll do it together. All right, we're back. Subtract 2x from both sides, and please understand that that negative stays on the y for now. Divide both sides by -1. And now we can see the slope of this line up here. The slope of this line is 2 because it's in slope-intercept form. So the slope of our line is going to be -1/2. Why? Because the lines are perpendicular, so you have to find the negative reciprocal. That means change the sign and flip the fraction. We also know 4, -3 is a point on our line. So obviously if we have a point and the slope, then we just use point slope form to write the equation of the line. So we got those answers. Good job. All right, so now we're going to go to some graphs here. You can see we have the graph of a line, and it says for each graph below, write an equation of the line shown. So in a previous class, we were given an equation of a line, and we were asked to graph it. In this class, we're given the graph of the line, and we're asked to find the equation. So we're going backwards. So in this particular graph, we can see the y-intercept is right here. And we can also see the slope. If we go up 1, 2, and over to this point here, we can see the slope is 2 over 3, because remember, the slope is rise over run. Now, I just want to be very clear about something. In order to find the slope, you have to find 2 points that are on the line. Now, please understand that you can't choose a point here or here or here or here, because we don't know what the coordinates of those points are. If you're going to choose a point, the point has to be at a corner of one of these squares on the grid. You see this point here? It's on a corner. It's on the corner of those squares. This y-intercept is at the corner of the squares. And so on and so forth. So these two red points are going to be the best ones to choose. And I'm going to color the y-intercept purple. That's a special point. So again, we count up 1, 2, and over 1, 2, 3. So the slope is 2 over 3. The slope is rise over run. So we can write, because we have the slope and the y-intercept. Remember, the y-intercept is where the line crosses the y-axis. So because we have the y-intercept, which is 2, 1, 2, and we have the slope, 2 over 3, we can use slope-intercept form because it's just easy. So y is equal to 2/3 x plus 2. So notice how I'm color coordinating everything. The 2 is the y-intercept. So as you can see, that's pretty easy. Let's try number 40 together before you try one on your own. So we're going to use the y-intercept again because we can see the y-intercept. The y-intercept is where the line touches, so I can see it right here. You see that down there? Again, I can't use any other points here or down here because our point has to be on a corner of a square so we can see exactly what the coordinate is. If it's not on the corner of a square, then we can't see what the coordinate is. So we know that this coordinate is, that y value is -3, or that y-intercept is -3, because you go down 1, 2, 3 to that point. And let's see, what points are we going to, so we're going to use that point there. And what other point can we use to find the slope? Again, the points that you use have to be on corners of the squares. So I can see that this point here is at the corner of a square. And so the slope is going to be, it's actually going to be going down, but technically that's still the rise. So the rise is 1, 2, 3, 4. I guess you could say -4 because it's going down, and the run is 1. So let me move this over a little bit. We're going to write slope-intercept form. Y is equal to the slope, -4 over 1, times x, plus the y-intercept. And actually it would be minus, because the y-intercept is negative, so it would be -3. And instead of writing -4 over 1, I'm just going to write -4. Actually, maybe I should just keep that, just so you see exactly what's going on. So the slope is negative because the line is going down from left to right. So hopefully you have the idea by now. Try number 41. Again, you're going to find the y-intercept if you can. That's where the line crosses the y-axis, and the y-intercept is going to go here. And then you're going to find 2 points that are at corners of the squares on the grid that are on the line. And then you're going to do rise over run to find the slope. And then you're going to use the slope and the y-intercept to find the slope-intercept form of the equation. So try number 41. When you come back, we'll do it together. All right, we're back. So the y-intercept is here, and luckily it's at the corner of the grids. If it weren't at a corner of the squares, then we couldn't use it, because we wouldn't know what the coordinate was. And then we can use, I think this point here we can use to find the slope. So we go up 1 and over 3. So now we have y is equal to the slope times x plus the y-intercept, which is -2. So I can just put -2. So if you got that answer, Good job. All right, try number 42, and when you come back, we'll do it together. All right, we're back. So the y-intercept is here, looks like. And if I use I can use this point, so it'd just be up 1 and over 1. So the rise is 1 and the run is 1. And because we have the y-intercept and the slope, we can use slope-intercept form. The slope is 1 over 1. But of course, you'd never write 1 over 1. You'd just simplify it to 1. But I just want to show you exactly what the process is here. And the y-intercept is 1. And I'm going to go ahead and simplify that down here because 1 over 1 is not a typical way to write an equation. So I'm going to do the same thing here. All right, so if you got that answer, good job. Try number 43. When you come back, we'll do it together. All right, we're back. The y-intercept is there. Whoops. Y-intercept is there. And let's see, we can use a point. Looks like we're going to have to use a point all the way at the end. Again, it has to be at the corner of the squares or else it's not going to work. 1, 2, 3, and then 1, 2, 3, 4, 5. So that's the slope. And I think I'm going to have to write my equation over here. So y, it's okay if you write your equation pretty much anywhere as long as it's not bumping into the lines and whatnot. Y is equal to the slope times x plus the y-intercept, which is 1, 2, 3, 4. It crosses at 4. So if you got that answer, good job. All right, try 44. When you come back, we'll do it together. All right, we're back. So the y-intercept is -1, it looks like, and I have to find another point at the corner of the squares to find the slope. And looks like it's, let's see here, I can only see up here. Looks like that's the best we can do. So 1, 2, 3, 4. 1, 2, 3, 4, 5. And that would be a -5, I guess. It really doesn't matter which one you put, positive or negative, as long as you understand that the slope is negative because the line is going down from left to right. So now we can write the equation. Y equals m x plus b, and it would just be -1 because b is negative. All right, so 2 more of these problems before we go on to some slightly different problems. All right, so try 45. When you come back, we'll do it together. All right, we're back. The y-intercept is at the origin, and we can use this point up here. We could also use this point down here, but we don't need more than 2 points. So up 1, 2, 3, and then over 1. So again, we have the y-intercept and we have the slope, which means we can use the slope-intercept form. And that equation simplifies to 3x. Y equals 3x. So if you got that answer, good job. Try 46, and when you come back, we'll do it together. All right, we're back. The y-intercept is at 3. And let's see, we can use this point here. That should work. So we're going down 2 and over 1. So the slope is -2 over 1. y-intercept is 3. And simplify that. So if you got that answer, good job. So in those problems, as you could see, finding the equations was pretty easy. And the reason it was easy is because we had the y-intercept. The line crossed exactly at the corner of the squares at the y-intercept. You see? Exactly at the corner in each one of these problems. Exactly at the corner. It crosses the y-axis. The corner of the grids. You see these grids? Let me use a different color. I just want to be absolutely sure you understand what I'm talking about here. Let's see, what color can I use? Yellow. So you got these grids, right? You got a grid there, a square there, a square there. See how the purple is right on the corner? It has to be at the corner, so the y-axis, or the y-intercept is right at that corner. But in the next problems, that's not going to be the case. So we can't really write the equations using the same methods. Because look at this. The y-intercept, it's not at a corner, so we don't really know for sure what that coordinate would be. Now I know what you're going to say. You're going to say, this is halfway between. Well, we don't know that. It looks halfway between 2 and 3. So you would think that the y-intercept would be 2.5, and it could be, but we just don't know. You know, you can't. It might be 2.5. It might be 2 and 7/12, which is almost 2.5. We just don't know, or 2 and 5/12. So you can't assume that we know what that is. So long story short, in these problems, we can't assume that we know the y-intercept. So what that means is that we have to use 2 different points. And just to make sure that you understand what points are at the corner of squares so we can see the coordinates, I actually wrote the dots in there for you for all these problems. I just want you to be sure that you know which points we can use. So we're going to use these 2 points, and we can find the slope immediately. So it's up 1 and over 2. So nothing different there. We're just finding the slope, the same methods. The only difference is we're not using the y-intercept. And we also have 2 points. This point here would be -1, 2, and this point would be 1, 3. So we have 2 points, and we have the slope. So what we're going to do right now is we're going to write the point-slope form of the equation, because it's just easier that way. In this particular situation, we want to write the point-slope form. So y minus, and what point should we use? Should we use this point or this point? Well, it doesn't really matter, but you have to stay consistent. You can use either this point or this point, but not both. Don't switch them around. So I'm going to use this point. So y minus 3 is equal to the slope, which is 1/2. Should probably write that in red. Times x minus 1. And maybe I can color code that so you know exactly what's going on. You know what? I'm going to make these points black. So I don't confuse you. The red is always going to be the slope. All right. On to the next problem. So again, the difference between these problems is that we can't use the y-intercept because it's not crossing at a point where we can see what the actual coordinate is. So we have to use just two random points, and then we have to write the point slope form. At least that's the easiest way to do it once you have the slope in a point. We have the slope in 2 points. So I'm going to leave that problem in the window. Actually, we don't need to leave it in the window. So we have 2 points. You can see I wrote them in red. And we can see the slope easily. 1, 2, 3, 4, 5, 6, 7, 1, 2. And this point up here is -1, 4. And the point down here is 1, -3. And color coding, so you can see exactly what's going on here. So there you go, that's the equation. I think I forgot to rectangle this one here. Alright, so hopefully you can see exactly what's going on here. So I'm going to leave those in the window. And hopefully this is zoomed in enough to where you can see this graph. So try number 49. Again, we cannot use the y-intercept. We have to use these 2 points here. So try 49, and when you come back, we'll do it together. All right, we're back. 1, 2, 1, 2, 3, 4, 5. And we have -4, 1, and 1, 3. So I'm going to use this point over here. So if you got that answer, good job. All right, try number 50, and when you come back, we'll do it together. All right, we're back. So I'm going to find the slope first. So we have 1 and 5, and I guess I can make that a -1 because it's going down. And this point will be -4, -1. And this point will be 1, -2. Whoops, that's the wrong value there. I'm sorry about that. That should be y plus 1, x plus 4. So if you got that answer, good job. Let me just color code these real quick. Again, this is point slope form that we're using. We could use slope-intercept, but point slope form just happens to be the easiest way to do it in these particular problems. So try 51, and when you come back, we'll do it together. All right, we're back. So that's 1, 2, 3, 4, 4 at the bottom, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 at the top. And that point is -1, 5. And this point over here is 3, -5. I'm going to use this point. And this is going to be, that'd be a negative 10, I guess. Negative 10 over 4 x plus 1. Color coding. And I'm going to simplify that slope. We don't want to leave it as negative 10 over 4. Divide both sides by 2 and you get negative 5 over 2. And there you go. So if you got that answer, good job. Try number 52. When you come back, we'll do it together. All right, we're back. 1, 2, whoops. 1, 2, 3, 1. I think that's right. I'm going to use the far point. So if you got that answer, good job. All right. 2 more of these types of problems, and then we'll go on to some really easy stuff, and then we'll be done with this class. So try number 53. When you come back, we'll do it together. All right, we're back. 1, 2, 3, 1, 2. And this point is negative 1, 0. And positive 1, negative 3. So using point slope form again, I'm going to have to write it over here. And let's see, I'll use the far point. Just double checking that. Everything looks right. There you go. So if you got that answer, good job. All right, try 54. It's the last one of these types of problems. And then we just have a few easy things to do, and then we'll be done with the class. So try 54. When you come back, we'll do it together. All right, we're back. Let's see, up 1 and over 1, 2, 3, 4, 5, 6, 7, 8. So this point would be 3, negative 1, and this point will be, looks like negative 5, negative 1, actually negative 2. And, yep, that's right. So y plus 2, I'm going to use the closer point. And color coding, just so you know where all the numbers are coming from. And remember, it's the opposite signs when you plug in that point. All right, so if you got that answer, good job. So like I said, we just have a few more easy things to do. Looks like we have a lot of problems left, but it's not really a lot because these problems are going to be easy. So we're almost done. All right, so 55. Now we're going to learn how to deal with vertical and horizontal lines, but this is really easy. We have a vertical line. If the line is straight up, it's called vertical. If it's a flat, it's called horizontal. And it says, for each graph below, write an equation of the line shown and identify its slope. So we haven't learned how to write equations of vertical and horizontal lines yet. So that's what we're going to do right now. Now notice that all the points on this line, they have different y values. For example, this point, probably should have used a different color, but this point here has 1, 2, 3, has x value of 3 and a y value of 1. This point has an x value of 3 and a y value of 2. This point has an x value of 3, y value of 3, and so on and so forth. What do you know? What's this? What is similar in all these ordered pairs? Well, obviously, the x value is the same for all of these. The y value is different, but the x values are all the same. So because the x values are all the same, the way that we write this equation is we just say x is equal to 3, and that's it. You're done. It's that simple. X is equal to 3. Because all the x values are constant. They're always 3. It doesn't matter what the y values are. The x values are always going to be 3. So because the x values are always 3, we just write a vertical, the equation of a vertical line is just simply x equals 3. I know what you're thinking. You're thinking there's got to be more to it, right? Nope. Writing equations of vertical and horizontal lines is really easy. Let me just bring this down here. Let's bring it down over here. So that's the equation of the line. I guess I can just write it right next to the line. Now we have to find the slope. Now remember, slope, if you use 2 points, slope is equal to y2 minus y1 over x2 minus x1. So let's use 2 of those points. Let's use this point, and we'll use this point. So this point was 3, 1, and this point was 3, 4. All right, let's plug it into the slope equation. So we get 4 minus 1 over, I'm going to move that down. Four minus 1 over 3 minus 3. 4 minus 1 is 3, and then we get 0 in the denominator. Now, if you recall, when you have 0 in the denominator of a fraction, that fraction is what's called undefined. We talked about that a little bit in my arithmetic course. We didn't talk about it a lot, but we did talk about it a little bit. So you cannot have a slope with 0 in the denominator. So I'm just going to write UND, undefined. So that's the answer, undefined. So you don't have to do these calculations. You do not have to do these calculations. They're just showing that to you so you know why the slope is undefined. All you have to do is just see that it's a vertical line and memorize that it's undefined. The slope is undefined. So you have to memorize that the vertical line is written as x equals whatever the x values are. And you have to memorize that the slope is undefined. So it's pretty easy. Now we go to horizontal lines. Notice that the y values of all these points are all the same. It would just be the same logic. All the y values are the same, so the equation of that line is just going to be y equals -1. Y equals -1, and you're done. We just have to find the slope now. Now, if you use the same logic, use this slope equation and use those points. Use any points you want, a point here, whatever. Then you're going to find that the slope of a horizontal line is always 0. By the way, I should have written m equals undefined. M is undefined. So up here we can write m is always equal to 0. The slope of a horizontal line is always equal to 0. So as you can see, these problems are really easy. They're all going to be pretty much the same. So for number 57, we have a vertical line. And where is it positioned? It's positioned right here. What is that x value? So that x value is going to be 1, 2, 3, 4, negative 4. So x is equal to negative 4, and that's the equation of the line. It's so easy. Because x is always negative 4. Now what is the slope? Well, we just memorized the slope is undefined because it's a vertical line. What about number 58? Number 58, it's not going to be x is equal to something. It's going to be y is equal to, y is always equal to what value? The y values of all these points are all equal to what? Well, if you said 2, you're correct. So the equation of that line is just going to be y is equal to 2. And the slope we memorize is always 0 for a horizontal line. Again, this is just memorization stuff. It's very easy. So now you try 59 and 60, and when you come back, we'll do them together. All right, we're back. The equation is going to be y is equal to 1, and the slope is undefined. Remember, we always notate slope with an m. For number 60, the equation is y is equal to 3, and the slope is 0. Slope of horizontal lines is always 0. Try 61 and 62. When you come back, we'll do them together. All right, we're back. The equation of this line is x equal to negative 1, and the slope, as usual for a vertical line, is undefined. So if you got those answers, good job. For 62, the equation is y equal to negative 4, and the slope of a horizontal line is always 0. So if you got that answer, good job. All right, last problems here, last problem set. We have 1, 2, 3, 4, 5, 6, 7, 8 problems, and we'll be done. These are really easy. Now we're just going backwards. You're given the equation of a horizontal line, and you're asked to draw the line. So y equals 4, that'll be about here. I just realized I have to move my equation up a little bit. So that would be, I have to make that a little bigger, sorry about this. Make that a little bigger. It will look like that, very easy. Don't go past your window there. All right, and it says find the slope also, so the slope would be 0. Slope of a horizontal line is always 0. So you draw the line and you mark the slope. X equals negative 3, that's a vertical line, and that would be here. So that's the line graph. If we graph the line, that's what it looks like, and the slope is undefined. All right, so as you can see, these are really easy. Whoops, I have to rectangle these answers. Wait, no, I'm sorry. All right, try number 65. And when you come back, we'll do it together. All right, we're back. Y is equal to 3. That would look like this. And the slope is going to be 0. Slope of horizontal lines is always 0. So if you got that graph, good job. Try 66, and when you come back, we'll do it together. All right, we're back. X is equal to 1. So that's going to be a vertical line. Whenever it's x, it's a vertical line. And the slope of a vertical line is always undefined. So if you got those answers, good job. All right, try number 67, and when you come back, we'll do it together. All right, we're back. Y is equal to 1. That looks like this. It's right at 1. And the slope of a horizontal line is always equal to 0. So if you got those answers, good job. Try number 68, and when you come back, we'll do it together. All right, we're back. It's a vertical line at x equals -1. And the slope of a vertical line is always undefined. So if you got those answers, good job. 2 more problems. Try number 69, and when you come back, we'll do it together. All right, we're back. So y equals 0. That's going to be right on top of the x-axis. And the slope of a horizontal line is always 0. So if you got those answers, good job. All right, try number 70, and when you come back, we'll do it together. All right, we're back. X is equal to 2, so that's a vertical line. And the slope of a vertical line is always undefined. So if you got those answers, good job. So that was the class today. Here's all the work that we did. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. Here's the homework for today. I wrote the problem sets myself this time. So get screenshots of these first 2 pages, or a screenshot of the first 2 pages, and a screenshot of these problems, and these problems, and these problems, and these problems. Now, as you can see, I have the answers for the first 20 problems. They're rectangles as usual for my problem sets, but over here I have the answers for problems 21 through 28. So get a screenshot of this, and be sure to check all your answers, show all your work completely and correctly, do every single problem, and check all your answers. And remember, if you get something wrong, that doesn't mean that you get to go watch TV. If you get something wrong, that means you have to figure out what you did wrong and go back and do the problem correctly. So that was the class for today, and I'll look forward to seeing you in the next class.